Okay, wonderful. Welcome to the Advanced Water Heating Initiative Commercial Working Group meeting for today, February 20th. And can I get someone to read the antitrust? Kashmir, since you were the only one recently on camera, it might bother you for it.
Yes. Okay, antitrust statement. The Advanced Water Heating Initiative is a member-supported collaborative of professionals from across the United States. Our diverse membership includes numerous competitors, and care must be taken to scrupulously abide by federal and state antitrust laws. Members should remember that antitrust compliance is important at all times. At this and at other AWI meetings, participants should not discuss competitive pricing, profitability, allocating markets or customers, or promotion of a particular product or an accessory. So thank you.
Excellent. Thank you very much. Now we'll get into our call agenda. Bunch going today and a lot of exciting things crammed in here. So we have our AHR recap and hot water forum look ahead. So I know AHR was just this past week, and then we have the hot water forum coming up in early March. So definitely an exciting time for conferences. And then we have a manufacturer spotlight with Teal Systems, some guidance for restaurants in California installing heat pump water heaters. And then lastly, a case study on heat pump water heater cluster installs in low-rise multifamily. So some great variety today, and excited to hear from all of our presenters. If we have any new participants in the Advanced Water Heat Initiative, kindly come on camera for a bit and introduce yourself and where you work.
I am Barry Hooper. I haven't joined before. I'll be speaking to you a little bit later, but I'm with the Environment Department in San Francisco.
And I'm his colleague, Nick. Nice to meet you all.
Awesome. Thanks, Barry and Nick. Good to have you on.
Hi, my name is Eduardo Hernandez. I'm with Teal Systems, and I'm going to speak about our product and our company.
Great. Thanks, Eduardo, and thanks for presenting.
Thank you. Thank you for the invite to be part of this group.
Absolutely.
Hello, I'm Jon Lundstrom with Green Hammer Design Build, also presenting later and haven't been a part of this group before, but thank you for inviting me.
Yeah, thanks for being on. Okay, thanks, y'all. So, speaking of the Hot Water Forum for week after next, the Commercial Heat Pump Water Heater Group has its own track. So many of the folks you see on this call, such as myself and Joe and Kashmira, and yeah, and John Heller also, we will all be presenting about commercial and central heat pump water heaters at the Hot Water Forum. So on its own track, definitely attend that. If you're at the Hot Water Forum, we'd love to see you there. Additionally, we have a central heat pump water heater tour. It's at in Portland, adjacent to where the ACEEE Hot Water Forum is taking place. So this is going to be on Monday, March 3rd from 3 to 5 p.m. You can register at the link in this right here, and I'll also pop this in the chat in a bit. And yeah, if you want to check out the Nile E360 system, it's part of both the two benefit projects, Magic and Scaling Up, which we've talked about before on some of these calls. So awesome opportunity to get a little tour of this system and what's going on. Then we also have some AWHI announcements. So the State of the Market report just came out, ton of hard work that went into that. Joe's shared some slides before of the early history of heat pump water heaters and kind of what the market status is. And there are also some exciting projections for the future growth of heat pump water heaters and kind of some of those regulations kicking in from the federal level and some of the efficiency standards that will hopefully be enforced in 2027 through 2029 and likely lead to a big uptick in heat pump water heater adoption. So if you want to learn more, definitely check out the report. It also features product tables on all the available heat pump technologies for central systems that we're aware of right now. So yeah, definitely take a look in the report and learn more. You can click on the link in the slides. In addition to the State of the Market report, there are a couple other upcoming resources. So there's a DIY resources webpage coming late this month. There's also a Central Heat Pump Water Heater market research coming out in March. I'm working on that. So that's kind of a more deep dive into Central Heat Pump Water Heater technologies, what's available on the market, different configurations, and then also some insights for manufacturers on where in the country it might be best to target based on demographics, data, and favorable economics. Then there's a multifamily in-unit memo coming in also in March, and then a cost compression report in April. And that cost compression report is more on single-family homes, but still some of the findings will apply. We also have several upcoming AWHI webinars, new refrigerants on February 26th. So that's next Wednesday. So definitely register for that one because it's right around the corner. And then same thing for ground source heat pumps. We'll also be talking about some thermal systems. So that'll be a cool one on the 27th. And then on March 12th, this isn't mentioned here, but we have a upcoming webinar on package terminal heat pumps. So all of these will feature several manufacturers and implementers of these technologies. So if you're interested in learning more, definitely sign up. AWHI, as always, is also posting videos and recordings on YouTube. So definitely check us out there if you missed any sessions and want to catch up. And with this, I'm going to turn it over to John Heller. John, if you're on the call, would you mind talking about this slide?
We see Jon Heller. John joined us yet?
I'm happy to
I
talk
have.
about it.
You can
Is
go
John
for it,
here?
Kashmira.
I am here.
Oh.
Sorry about that.
To you.
Sorry, I just joined. Are we
No worries. So we're just on this slide, John.
I'll
I'm
cover
talking
it
about
while
the
you catch
alignment.
up. I'll just cover while you catch up. So
Yeah,
there's an
perfect.
ongoing initiative underway, a coalition of the willing, as some of us like to refer to ourselves, to get alignment between the Energy Star identification of central heat pump water heaters, the CE Consortium of Energy Efficiencies specification for central heat pump water heaters, the advanced water heater specification that NEA has on its website, and the associated listing of QPL products on that website, what the California Energy Commission is calling out, and of course our Advanced Water Heater Initiative overall. So this is a loose alignment of the willing that are wanting to all head in the same direction for this specification. Recognizing that there are some differences in the different organizations now, but that's the current state, with the future state headed all towards the same direction of the qualified products lists in the advanced water heater spec. John, I don't know if you have anything you want to
I would
add
say
to
one
that.
of
You are
the
leading that up.
yeah, one of the primary intents is to make this clear and easy for the manufacturers to know how to test their products, what needs to be submitted to the various agencies so that they're all asking for the same thing, and just provide some stability and regulation to the industry.
Consistency.
Yeah,
Right.
consistency. So what the California code
markets.
requires is the same thing that the advanced water heating spec is requiring, is the same thing that Energy Star is requiring. And that will make it much easier to feed these products into utility programs in the future.
And if folks have questions about that, John, where should they reach out?
They can reach out to me. Ryan Hamilton at CEE is also helping to organize this.
And maybe
Yeah,
AWHI
if people
too.
want to, people could also take a look at the the new documents coming out of Energy Star for their test requirements and draft specification, which is very closely aligned with the advanced water heating spec, not exactly aligned. And those are the conversations that'll be happening over the next few months, is to work out those small areas of misalignment and try to get it all clarified.
Sweet.
Hi,
Thank
this
you,
is
Joe.
Abby
Leadership
from
on that.
This is Abby from EPA. Can I add one thing to that because I'm involved in this effort also?
Of course.
Yeah, please.
Yeah, the primary thing is to get the testing aligned. We are also interested in having the requirements of the various programs aligned. That is a secondary thing, but at the very minimum, we hope to keep them from contradicting each other.
Agreed.
Awesome. Okay, so yeah, then John, do you want to give an AHR recap as well?
Yeah, so there was a great showing by commercial heat pump water heater manufacturers at AHR. A lot of impressive progress being shown in the maturation of these products and the way they're showing up in the industry. A lot of the leading manufacturers really showing off their full system approaches to delivery of these products rather than just the heat pumps, also showing the rest of the systems. A lot of manufacturers, like last year, many manufacturers showing off new heat pumps, including several of the boiler manufacturers showing off heat pumps that they're marketing as being able to be used in dual fuel systems, so with gas backup, for example. None, as far as I could tell in the conversations I had, none of them were really prepared to have full system, fully baked systems that have heat pumps and gas equipment providing hot water to a single building in terms of having the controls package and sequence of operations really standardized and proven. But it's interesting to see the industry moving in that direction. But I would say that there's still a large gap between having a viable heat pump product and having a system fully baked and standardized and tested, delivering repeatable, reliable water heating systems. The other interesting thing I thought that I saw at AHR in the heat pump water heater space and air to water heat pump space is that the refrigerant transition is definitely underway. And I don't think there's going to be any going back, regardless of any changes that might come from the feds. Investments have been made by all of the heat pump manufacturers in this transition. And so the manufacturers are wanting stability and predictability. The concerns about the tariffs and trade wars and changing regulations, it was palpable at AHR, and not a good thing for the industry overall. But in terms of the refrigerants, it seems that most of the US manufacturers have been moving in the direction of the 454B refrigerant for a lot of this equipment, while the Asian manufacturers are moving towards R32. There's still a pretty strong desire, particularly from smaller US manufacturers, to make R290 available for use in HVAC equipment in the US. That's a strong desire and need in the US industry that's really holding back a lot of the US heat pump manufacturers. So overall, really exciting show and a lot of progress for this industry. Anybody else have comments that they wanted to throw in about that?
John, I would add that we also had more manufacturers wanting to work with their local distributor reps to get additional products on the QPL. So that was some really positive feedback.
Yeah, thank you for that. Abby's got her hand up.
Hi, thanks. This is in regards specifically to the Energy Star specification, but I think it has broader applicability. I talked with a number of manufacturers about the spec, and one question that came up is who would be the Energy Star partner? If you've read the draft, it's clear that there needs to be one organization that is responsible for the performance of the heat pump water heater as a system. And not all, some, but many of the heat pump water heater manufacturers are not really in a position to do that. It's not their business model. It's not what they're thinking of. There are others which are much, much closer and or are interested in getting into the business. But that did kind of beg the question of if it's not, Lochinvar who makes the heat pump unit, who is it? So I just wanted to throw that out there.
Yeah, and that's the same question that the NIA's qualified products list is addressing there. And so the system manufacturer that's listed on the qualified products list can either be a manufacturer like Lars, who is providing all of the parts and pieces of the system, or Link, also providing all the parts and pieces, or it could be a third-party packager that's creating a fully packaged skid, like Water Drop, which is packaging up the Sanco 2 product into a full heat pump water heating system, or it could be a distributor like Johnson Barrow, who's selling a Colmac heat pump with a particular line of tanks and a particular line of controls to provide that full system. So I think that the thinking needs to shift from the heat pump manufacturer to the system manufacturer or system supplier.
I agree. I think it's a little uncomfortable for the heat pump manufacturers, but it is a reflection of what actually matters for performance.
I think, thanks for that. I was thinking we might move on to the next topic just for schedule. And I was wondering, John, since we have you on, if you could introduce our next presenter from Teal Systems, Eduardo.
Oh, great. Yeah, I'm really excited to have Teal talking to us today. I think they bring a unique approach to delivering these systems to the marketplace, which is more of a complete wraparound service of design, install, maintenance, and operation that really removes a lot of the risk for the owner and makes sure that these systems operate well on into the future. So super excited to see what they have to show us today.
Great. And Eduardo, do you want to drive slides, or it looks like, Joe, you're sharing now?
Sorry, yeah, Eduardo, what do you prefer? Do you want to drive your own slides? Do you want to take control of this screen? What's your preference?
If someone else wants to drive the slide, I'm okay with it.
Okay, great. I can do that for you.
Thank you. And John, thank you for the introduction. You probably worded better than I would. But I'm here to present what Teal does and our new approach to central plants. Unlike what John was saying, unlike the conventional approach that you have OEMs installing equipment, OEMs providing equipment, contractors doing the installation on site, and then they walk away, and then they let the customers handle their own central plant. At Teal, we do things a little bit different. We actually sell hot water, and we have other products. We sell chilled water as well as a service, which means we take on the whole system, and then we design the system, we install the system, we own and operate the system. We do contracts with the end customer, and we take care of the operation of the entire system. If you don't mind going to the next slide. Just some history on Teal and information. So we're actually, we have 7 offices across the US, across 16 states, where we have many of our systems installed. Yeah, we have a decent presence, mainly in the South, but it's been growing. You can jump to the next one. So some history on Teal. A company started in 2004, doing the same model that we do right now, which is doing central systems. They started with domestic hot water, central boiler systems, where Teal provides the equipment, and they own and operate the equipment for the duration of the contract, which is typically 10, 15 years. In 2012, we launched a domestic hot water and hydronic gas fire system. In 2020, we launched our chiller plant system using the same model, selling chilled water as a service, and Teal owning and maintaining the equipment for the duration of the contract. And most recent and more relevant for this group is our electric domestic hot water system, which uses heat pumps. And that's what I'm gonna talk about today. The key for us, we do everything in-house, even the controls, something we developed, which gives us the ability to monitor the equipment. So not only we install, we monitor the equipment 24/7. We're gathering a lot of data points in the system, so we are able to provide. Our goal is to have an uptime guarantee of 100%. And the way we get close to achieving that is by tracking every single data point that we can on the central plant, doing a preventive maintenance. We know every amperage of every pump, so we know when it's about to go off. Same with heat exchangers or heat pumps. We know everything that is happening on the system, and we typically act before the customer even notices there's an issue. So we're always gathering data 24/7. We deploy boots to the ground when it's needed, and we track everything in our network operations center, where we have people year-round 24/7 monitoring all of our systems. Just a recap on our 4 systems that we're able to provide. The one you see on the left is a conventional. I think I got a question. Let me see what that is. I forgot. I didn't see a question, but yeah, I'll ping me with questions if you have. So our first system is our domestic gas fire. Probably not relevant for this group, but that's the one we have. Condensing boilers, and we own and operate the whole system, as you see on the picture, and we guarantee delivering hot water to the end customer. The next one is our most recent, which is our heat pump system, and I have more slides next to that to show you that. The third one that you see is our domestic hot water, combination of domestic hot water and hydronic heating for space heating, mainly for very cold climates, Colorado, Minnesota. It's a gas fire system. And our chiller system, which uses like air-cooled chillers to provide chilled water. And yeah, those are our 4 main core products that we build. The ways our systems are attractive to the end customer is because they only pay a one flat fee at the beginning of the project and a $500 renewal every year, and we get paid by providing the service to the mostly multifamily. That's what we do. And we get a fee per apartment per month, and that's mainly why we recover our cost. Like I said, we have a flat fee, which is mainly applicable to boiler systems. On heat pump systems, it's a little bit more complex because it's more equipment. And yeah, so that's kind of how we operate. That's our pricing structure. So we charge the end customer per unit $16.75 per unit per month, which is passed through the resident through a fee, which I understand some regions are harder to have those fees. So we kind of work with customers so they can pinch in a part of that cost. Yeah. All right. So our more recent product, the reason why I'm here is we have our first system that we deployed and we install. It uses in this case, it uses the QHV heat pump systems, but we're looking at more heat pump manufacturers as well. Yeah. And like I said, what we do the full system integration. We combine the mechanical systems. We have knowledge of the plumbing systems, and we have our own in-house developed custom controls. So we combine all that to provide our service to the end customer. We work on the early stage of the projects, doing design collaboration, making sure everything is managed through the contractors. We provide maintenance and warranty, which means if something fails, the customer does not get a bill. We cover that ourselves. So it's part of the initiation fee that we charge the customer. And we charge, we monitor all of our energy use, which I understand for heat pumps is gonna be critical. So we're gathering a lot of data that we get that we track every single component, temperatures, flows. We're measuring amperage across all systems. So we're gathering massive amount of data just because that's the way our model works. But we want to be ahead of the curve when something's about to fail, and we replace it so there's no downtime. And like I said, we do this 24/7 monitoring. So that's a representation of the system we provide. We're not OEMs for the heat pumps. We use a third-party heat pumps, but we do the whole system integration. We have everything is modularized and scalable. We put everything on skids. On our shop we land on all the equipment and we lay out the piping supports as it's gonna be on the field. We deploy to the field and we actually do the install of that same system. And what you see is some pictures of our first system that we manufacture. You can see the material grade is a little bit higher than maybe what other OEMs do, or maybe other contractors do, and that's because we own and maintain the equipment for 15 years. So we want to make sure it's close to as industrial grade as we can, and everything is skid mounted. Like I said, all the piping is laid out on our shop. So we disassemble that and we reassemble everything on the customer site. That's another. I think there's a question.
Eduardo?
Yes.
Yeah,
go
Eduardo,
ahead.
there are a couple questions. Folks have their hands raised.
Okay.
I'm not sure if you can see the chat, but
Okay. Let me go to chat.
Phoebe from Seattle says, "Are you monitoring the system efficiency as well?" And
We
then
can.
after you answer
Okay,
that, I
Yeah.
was gonna say there are a couple other people, so I just encourage them to take turns.
Okay. All right. Let me go to the questions. I saw there are some notes coming in. So what's the first question? Is the monitoring of the energy? Yes. So the answer is yes. Since we're tracking temperatures, we're tracking a power consumption, we're tracking flows. We have the capability of tracking energy efficiency of the whole system. Our whole system is not just the heat pumps and storage tank. We do everything in between up to the return pumps that go to the building, which is the tying point for the contractor. And then next question is, for an installation in place, you can accommodate skid? Yes. The answer is yes. We'll try to do skid mount everything that we can on small skid that can be brought into a conventional to a regular door. But yes, there's some instances where we get asked if we can do everything, and the answer is yes. We have the ability. We'll take a look case by case, but we can work with the end customer to sort this out.
And Amin has his hand raised. Amin.
Go ahead.
Oh, yeah, a wonderful presentation. This is really great to see. I remember seeing some similar business models in Canada many years ago, and it's great to see that in stateside. Yeah, I had a question kind of regarding on that efficiency and COP. Looks like you have the ability to do COP. Are you considering a business model where you maybe guarantee a certain level of performance, or potentially working with utilities to provide a certain level of performance and get some rebates and incentives for the work that you do?
Yeah, for sure. That's a big, and obviously it is something new for us. But since we're tracking every data point in the system, we can track efficiency, and we can meet. I mean, we know what. Yeah, we can prove exactly what we say we're gonna do. Yes.
Wonderful.
Actually,
thank you.
yeah. This project, we're starting it up for the scale up project. Where I think some of that efficiency and power consumption and performance is going to be measures.
Great. Yeah. Thank you so much.
Thank you. Who else has his hand raised? Go ahead.
I think Abby, you were next. Or is that an old hand?
No, that's right. I have another question, which is, are you now, or do you have the potential to sell demand flexibility services to utilities also using this equipment?
Yes, we can do that as well, and that's part of the testing we're going to be conducting. To align with those utilities and do demand response for sure.
Yeah, so I was going to say that we are monitoring one of Teal's first systems as part of the DOE Scaling Up project, and we will be metering those in a way that we can deliver measurements of full system COP that aligns with the Qualified Products List definition of full system COP, and we'll also be demonstrating the load shift capability of that equipment and baking that into the controls so that Teal could deliver that. And Eduardo, if I'm not mistaken, you're paying the utility bills for the water heating directly, correct? And then collecting the monthly charge that covers equipment and utilities from the customer?
I'm sorry, say that one more time.
Does Teal pay the utility bill for the water heating system, or does the customer pay that?
The customer pays for that. We don't get into billing, and neither get into billing each of the units. We let the customer handle that. We just
So the monthly charge is for equipment and maintenance, not for energy.
Correct. It's
Okay.
for the service. Yes. And I think that's the last slide on my presentation. If there's someone else.
I have one more question.
Go ahead.
One more question, Eduardo. Are you integrating dashboards? These are going into multifamily buildings. I have seen that elsewhere to really get the what is it there? I want to say residents to actively participate in the savings of the energy savings of the project. So I don't know if you're planning on using any sort of dashboards that are shared with others.
So we do dashboards of the performance assay system. we don't get like to individual units and dashboard perform and track performance per unit, but we for our equipment only. Does that answer your question?
Yeah, for your equipment though, would you be making that, visible? Because I think you said you're going into multifamily buildings, so I don't know if that's part of the lobby, where they have energy dashboards displayed or anything like that. That's something you're considering.
Yeah, so I mean, we have access to that. We have worked with customers that they want to see they want to have access to the trends that we're seeing. And yeah, we have work and we give them like access to data points they want to see, not to everything, because some things are proprietary. But yeah, that's something we work with customers so they can see if they're interested to see supply temperature 24/7. They certainly can.
Eduardo, I had a question. It's actually a two-part question. Can you compare just percentage-wise how much higher upfront that initiation fee is for the heat pump versus the gas? Because I imagine we're always talking about the high upfront costs of heat pump water heaters. So yeah, percentage-wise, how much are building owners who are going to go for the heat pump looking to pay more than their gas? And then the second part of the question is, can you talk about any sort of flexibility that Teal? Sorry, somebody just muted my. Can you talk about any sort of flexibility between the monthly payments versus the initiation fee? Like, could an organization that doesn't have that upfront capital pay higher monthly fees and have a lower initiation fee? Thanks for that.
Sure. So your first question is on initiation fee. Definitely, the heat pumps they're higher initiation fee than our boilers. Like on our boiler system, it's a flat fee, whether it is 1 million or 6 million BTUs MBH a system. For a heat pump is based on the size of the building, because the bigger it is, the more mechanical equipment you have. It is definitely a minimum 4x of the initiation fee compared to gas. But what we have seen compared to a customer paying CapEx, once you factor in like the system integration, the controls, the installation, it comes up to about less than half to what you see on CapEx. And we've seen that on like chiller systems and these heat pump systems. Yeah, definitely big advantage for the customer. And the other question is, yes, so we work with customers if they want to pay more upfront and they want to pay less per month. We work with them to try to get to a point where everybody feels comfortable. We do that a lot on our chiller systems. They can pay a bigger fee upfront and very low monthly a monthly fee. Yes, that's something we take case by case, but yeah, we have the flexibility of working with the end customer. Right, and I think that's about everything I see on questions. Yeah. So thank you, everybody. I hope you enjoyed the presentation, and if you have questions, feel free to reach out. I can put you in contact with our salespeople. I'm more technical, so I can talk more on technical side, not commercial. But yeah, thank you for the time.
Thank you,
I have
Eduardo.
a quick question.
Oh.
If it's in the chat, so it sounds like you were comparing CapEx, but if I understand correctly, you're mostly doing gas and these electric heat pumps. And it sounded like you said the CapEx of the heat pump was half. So typically there's an OpEx. Maybe you can't speak to the OpEx because that's buried in your monthly fees, but you probably have to pitch to a customer. Here's our CapEx difference between gas and heat pump, and here's our OpEx difference. And can you just speak to that? Because everybody here is really curious. Gas prices fluctuate. Some people are trying to electrify and decarbonize, but obviously if the gas numbers are super less expensive than the electric heat pump numbers, we're going to have a problem, if not immediately, certainly after 2 years of everybody experiencing that the heat pump's much more expensive. I apologize if I missed it, but can you just maybe comment on that? Thanks.
Yeah, so that's something we can do on a case by case basis, depending on location. Mainly, like nowadays, we get asked from end customers, can you give us price for gas and heat pumps? And primarily, they're going not only for the initial capex or fee, if you will. They go more about the requirement, the regulations, and incentives with the heat pumps. Operations, that's something we can work. Yeah, something we can model and work with the end customer. We typically don't get asked that a lot, but if you have a particular case, we can work with you, and we track the data. We track our data for our gas system. We have 20 years of OPEX of the gas system, so we know that pretty well. For heat pumps, it's relatively new, so we kind of have to do an estimate on those.
Thanks so much, Eduardo. Really appreciate it. Thank you for the great presentation. Yeah, please do put your contact in the chat, as Kashmir is saying.
Sure, thank you.
Kashmir, should we move to the next presentation?
Yes, that'd be great.
Great. Well, I'd like to welcome Barry Hooper from the Department of Department of the Environment for the City of San Francisco. If I'm getting that right, Barry. To talk to us about guidance for restaurants installing heat pump water heaters. This has been a very talked about topic in this realm. So Barry, if you're here and want to come on camera.
Thanks, Joseph. Good. Let's go to the next slide. So be talking from a little bit different perspective. I think a different perspective than this group typically covers today. And just want to flag at the outset that we got a ton of help from a person I suspect is a regular participant, Amin Delega, who we heard from a bit earlier, and I will refer probably very technical questions to him. But the purpose of what I'm sharing today is we recognize a gap between what can be aligned public policy goals that we're not. So next slide, please. And the question our team at the Environment Department at San Francisco was asking is, why don't we see any heat pump water heaters, nearly any heat pump water heaters deployed as for food service water heating? And was that purely a technical issue, or were there regulatory barriers as well? Next slide, please. And we did find that there are both, and that there was a gap also in communicating with our partners in public health. And so really went back to basics with them to highlight that the reasons an agency like the Environment Department is focused on heat pump water heaters boil down to resilience, hazard reduction, and protecting those who need the most help. Next slide. And making sure that they're aware that there is substantial regulatory and other types of public policy activity in California that's ongoing as well as elsewhere. And so as a key example, we're coming up on the first deadline in 2027 where small water heaters intended to be for primarily residential use, but the regulation is about the BTU output, not the actual use of the water heater. There'll need to be 0 NOx for both sale and installation in the 9-county Bay Area that's covered by the Bay Area Air Quality Management District starting in 2027. And that is scaling up in 2031 to the vast majority of water heaters and boilers in both commercial and residential settings. Next slide. That's, as this group is probably familiar with, but we just want to always make sure with our, particularly with our partners in public health, they've become aware that that's not just an isolated rule, but actually part of a concerted activity in California, where both of the major energy regulators are moving to set up systems that favor the energy transition, and that we, as a state, have a commitment to broad heat pump adoption. And that the California Air Resources Board is publicly working toward its goal of adopting appliances that are not regulating nitrous oxide or other criteria air pollutants, but are regulating carbon dioxide emissions, but really with the same effect that a heat pump water heater is generally going to be the technology that can both fly with our energy code and meet these emission standards. Next slide. But why is there a barrier? Why was there a barrier? That became a key thing to learn about. And so you might have seen the coronavirus electron microscope images a lot over the years. This is a different one. This is the norovirus. This is the most common source of diarrhea, stomach upset, and just general illness. And the careful washing of hands with warm water, particularly in food service, is the main public health intervention to so really the basics, but to prevent its spread. And in that context of reducing spread of pathogens, next slide. For many years, California has had health regulations, and health regulations are really different from at the level of the law. They're quite different from a building code. So they just set some broad requirements that must be met for adequate pressure, for 120 Fahrenheit water to be consistently delivered at the point of use, so at the faucet, at the tap, and that means that our health regulators approve a water heating system in parallel with our building department staff looking at compliance with the energy, plumbing, electrical, and building codes. Next slide. And the regulations that the environmental health staff use to interpret those requirements, those are adopted locally. There is no statewide health code in California to kind of explain exactly how those requirements are met. And so California Conference of Directors of Environmental Health, so a group that includes each of the directors of public health, county level public health agencies across the state, has set up technical guidelines for how their staff can, as simply as possible, determine that a system is in compliance with that state code. And again, this is not connected to energy standards, building standards, or anything of that sort. So it's just another layer of regulation that is critical for a food service facility to meet. Next slide. And so those guidelines, they really boil down to a process for a storage water heater, and they do have, there's also provisions for instantaneous water heating, but just to keep it to apples and apples, we focused on storage water heaters, and effectively you need to calculate how much water is required, and that's a prescriptive process that's defined by the number of fixtures and to some degree their type. As well as there's requirements for minimum water heater recovery, and they relate to some of the particular applications, primarily whether there's washing of utensils that are used for human consumption, direct human consumption. And then the water heater needs to be able to meet those two criteria. Next slide. But again, the public health officials are not engineers, and they really favor and appreciate being able to make a straightforward yes or no decision. And so there's both a lookup table for sizing a water heater based on the number and types of fixtures, or a couple of formulas that can be used to determine if the water heater is sufficient. Next slide. And so the fundamental challenge is those guidelines were written back when not so long ago, we were really talking about two technologies for water heating, either burning gas or electric resistance. And, as you know, those are basically a dragster. If you need more output, then you put in more energy input. With heat pumps, they don't work the same way. And so there are no guidelines to specifically adapt or regulate heat pumps. And heat pumps don't function exactly the same way. Next slide. So the guidelines, and so really that meant that we need to share slides exactly like this with environmental health staff to highlight that the tank type systems, which are nearly all of what they see in project applications, those are banned already in certain new construction. Those are approaching a ban in terms of replacement. The gas tankless will be affected in the same way because it also produces nitrous oxide in its operation. While electric resistance is widely available, particularly in California, but to some extent elsewhere, just the cost of electricity is prohibitive, and particularly for the quantities of hot water consumed in a food service facility. And so while technically that's is definitely an straightforward option, it can be both lead to potentially astronomical construction cost as well for upsizing electric service dramatically, as well as very high operating cost. And so we really need for environmental health officials to have a path to approve heat pumps. And the solution to that, the next slide, is the stopgap solution that we have completed recently, is to recognize that a hybrid heat pump water heater, particularly the ones that are designed for commercial applications, is able to meet those guidelines. And so it combines, of course, electric resistance and heat pump. And the key component here is that we're just using the rules that relate to electric resistance water heating to verify that the electric elements in the heat pump water heater are sufficient to meet the current regulation. And then the recommendation is that the food facility actually operate the device in hybrid mode. And so the eco mode, where the resistance elements are locked out, that is just not able to comply with the current health regulations in California, as well as performance issues that are something that others on the call may talk about in a future forum. Next slide. There still is a limitation, though, that there's a limited number of commercial heat pump water heaters, just limited number of models available altogether. There's still, because this relies on electric resistance, there still are significant effects on electric service capacity and utility cost. But it's quite a bit better than not allowing the systems to be approved, particularly given the current or upcoming regulations. This is a clearly, in the short term, potentially very good solution for small businesses, smaller food service facilities. The regulation doesn't specifically limit heat pump water heaters to these facilities. It's just that that's the sweet spot between the equipment that's available and the way the current regulation is written and the workaround that we've published. And we published our workaround as a technical bulletin that jointly with our health department, but with a lot of support from Amin and his team at TRC, as well as the Food Service Technology Center. Next slide, please. And so sorry to jump the gun there, but we published a brief technical bulletin intended for environmental health staff to just guide them through the same content that's in this presentation today. We are coordinating with the Food Service Technology Center to do a broader training for health officials statewide in the coming months, probably in April, but I'm not sure a date has been selected yet. And then separately, there is a funded project that I'm going to refer all questions to Amin, but is developing the performance data for that would be necessary to propose regulations that recognize other ways that health officials might be able to approve a heat pump water heater-based sanitation system. The one thing that's really not covered in this talk today and in the bulletin, but is absolutely fundamental, is its plumbing design and equipment selection are at least as big of a factor, if not greater, to both operating and construction cost as the technology for the water heating itself. That is, though, being covered by the FSTC, and I think it'll be, it remains to be a big educational opportunity for industry in general to familiarize folks with the options to reduce or eliminate circulation loops via effective plumbing design, use heat recovery dishwashers to remove, that's typically a major source of water heating load, and other mechanisms that can actually help bring even a somewhat larger facilities calculated water demand for sanitation down into the range that could be served by one or multiple existing hybrid heat pump water heaters. So I think that's my last slide. I'm happy to answer a question or two if there are any.
Barry, I can get us started. And folks, yeah, please. Oh, great. My first question was just what size water heaters are we talking about in this technical bulletin? Are they the residential size, or the small commercial?
So the bulletin isn't specific to any particular type of water heater. What the device that's I think is most likely to be commonly used currently is 110 gallons, but it's just conceptually, is there a hybrid unit available, and what's the electric resistance input to it, and then sizing for using the heat pump as much as possible. So it's sort of similar in a way to what you do in residential, except for that the scrutiny and the stakes are higher for the performance of the system.
It looks like Amin has his hand up.
Hi, yeah, great presentation, Barry. Thank you for sharing this with the wider community. We're actually going to be at NCEEE. There is going to be some sessions on food service, and if anyone's interested, is going to talk through kind of the efforts in the last few years, as well as the work with the health departments and the lab testing we have going on, to starting with these unitary products. We have three units in parallel that we were testing in the lab to mimic usage in cafes, quick service, and full service restaurants. And the plan is to move to split systems thereafter. So there's going to be work activities going on. The goal is to help the health department update their sizing guidelines to allow split and unitary heat pumps. And we're trying to be, as cautious as possible through that process. And it's been wonderful to work with Barry and the team at SF Environment. And yeah, we have some momentum here. One of the key things is most of the US, almost practically all the US, follows the same kind of sizing guidelines. And so if we can have a breakthrough here in California, we're hoping that it can update sizing guidelines nationally as well.
Thanks. I mean, you may have just answered my question, but it was kind of what's the process for changing the sizing requirements to recognize output capacity instead of input capacity, and to recognize the use of storage to meet load as well, because those are the kind of the two key things that need to change to allow for larger heat pump water heater systems. So is there a timeline or a process identified for that work?
The timeline is not identified. We are meeting with them next week to kind of introduce our sizing guideline changes to some key health department staff. And then in April at a California symposium, educational symposium, will also share it with a wider group. So that'll be an iterative process, but you're right on, John. It has to do with ambient temperatures, indoors and outdoors, play a huge part. So they don't have that in their guideline. They don't have guidance for recirculation systems and how that impacts that return water, impacts the efficiency and the performance. Essentially, all they have right now is input rate, right? That's the only thing they look at, and they give you a reduction if you're just using disposables, right? In terms of sizing. And other pieces is they're sizing for your second hour recovery rate. So they assume that you've used all your hot water your first hour, and that everything is on at the same time your second hour. So it's a very different way of doing design, and we're trying to really help them come around to kind of the standard ways that designers do heat pumps. Yep.
And I just would add to that, just my perception of the process is there's the studies underway that, I mean, speaking to, and then there's the health directors need to accept those guidelines, those changes to their guidelines and publish them. I don't, because they are not a state agency or, you know, they're all public officials, but their work together is not really a regulated thing, even though it de facto creates a regulation since it's adopted by every health department in the state. There is a chance that they could act relatively quickly once they have clear recommendations. So that's the good side.
I want to get to our next guest, but Sabata, yeah, I saw your hand up, so I was going to see if you had your question. Go ahead.
Yeah, thank you so much. This is Sepida with Unroot Solutions. I work with CalMTA on food service water heating initiative ideas. So this is really exciting. I'm curious, you have a timeline of 2027 for your zero NOx emissions, right, Barry? I think that's what you mentioned. So if you, I know we don't have much of a historic, I guess, background with the CCDH, but what do you think is the ultimate timeline to actually for the health code to change so that smaller shops, once 2027 rolls in, actually could adopt heat pump water heaters?
Well, the one bit of sort of good news is, the 2027 deadline we do emphasize since it's real, but that would generally be for a 65, 70 gallon residential unit. And so we don't really expect it to affect the food service directly. We don't emphasize that necessarily with health officials because we'd like to create a little bit of urgency. So it does seem to me like, and the 2031 deadline though is very much would affect food service across the board in the Bay Area. So I think the parts are moving at something approaching the right speed. That they're just Amin's team has needed some time to do the engineering work that they've been leading, and I am just guessing here because again there isn't a single party in control of the timeline, is why none of us can directly answer your question. But there is such wide interest among health officials, and there is the technical work going on that it sure seems to me like 2026, 2027 would be reasonable times to hope for the guidelines to have been updated. And then there is a gap, right, for industry to be aware of and kind of process those changes and to adopt the different plumbing and design solutions that are implied that I think are also going to be pretty big changes. At least the mechanism to keep your costs low is a big change, and if you just have a different water heater, then maybe that can be sort of straightforward. But that's just really been apparent in talking with stakeholders and developing a guideline. Is with the technical bulletin to explain the guideline. But there's a gap in terms of awareness that's really partly on the health official side and partly on the industry side.
Okay, thank you.
Thanks, Barry. Really appreciate it. I think I'll move us forward for our last presenter. So really appreciate that great conversation. And I just want to welcome Jon Lundstrom from Green Hammer to come on camera. Jon, we asked Jon to be on today to kind of present a little case study, switching gears a little bit from food service to low-rise, small multifamily, and some interesting heat pump water heater solutions in this sector. So, Jon, do you want to take it away?
Yes. Hi, thank you for having me. My name is Jon Lundstrom. I'm an architect and co-director of design at Green Hammer Design Build. We are a design build company, so architects, builders, people that are just creative all around. We do a lot of certified projects, mostly focused on zero energy, zero water. We've done some living building challenges, and we work in the Portland, Oregon metro region primarily. So today I'm going to talk a little bit about a strategy that we've used on a senior living community. We've done multiple projects for them. This is their campus. We've done a courtyard building, which is a net zero called the Oaks, which is 12 homes. And today I'm going to talk about Trillium Townhomes, which are a series of 6 townhomes that are also certified net zero. We go through a local certification agency for these called Earth Advantage. This is the back of the buildings and what they look like. And when we started the design process on this project, we initially started out with trying to figure out, well, what's, the net zero goals for us, heat pump, and in particular, going with a Sanco unit is going to meet our needs. And it was really just about how do we fit these into residential layouts? How do we make them accessible and easy to get maintenance? And, one of the things that we find with essentially developers is, minimizing the amount of square feet for mechanical, maximizing it for the people. And so looking at a system that uses an outdoor compressor and an indoor tank was advantageous to our clients, and also because the senior community, noise is an issue. So doing a remote unit outside is something that was very appealing to Roseville in general. So I'm sure many of you are familiar with the advantages of these. They work well in our climate for us because they go down to -20. We don't see -20 degrees in Portland, Oregon. Generally, we'll get down into the teens at the lowest. So they work really well for us. I think one of the challenges was, again, maximizing space for the occupants and minimizing it for our the space for the equipment. So we went through a lot of iterations on how to locate the equipment. And so here's a plan showing the 6 units. There's 5 of them that are kind of side by side, and then 2 that are back to back. The circles represent where we decided to locate our storage tanks. And then the rectangles are where we located the outdoor compressor units. We ended up working on a shared distribution system. So we have 1 tank serving 2 homes. We found that there was great space savings in that, less equipment, also just a cost-effective strategy all around from just upfront installation costs. Obviously, as well as the operational. So the other trick that we combined with this was really just the distribution. We always are trying to reduce the amount of cold water in our distribution, get the hot water there quicker. So we looked at pairing a hot water recirculation system with the Sanco system. And so, as you can see here, Unit A has a tank, D has a tank, and F has a tank. Those tanks are located inside the thermal envelope, and then the compressor units are located outside. The shed that you see with kind of a louvered door on it in the center picture, inside there are 2 stacked compressor units. A unique piece of that is the room that's next to it is actually has some IT equipment in it serving this building and some other buildings on campus that generates a lot of heat. So we actually have a pass-through fan that is moving hot air from the small data room into this room to just help in some efficiencies and also help cool down the data room. The other one is, I don't have a picture of it, but it's located outside. The unique layout of trying to reduce the amount of footprint inside one of these units really became a little bit of a puzzle, Jenga. And so I put a diagram on the left side that shows sort of a unique strategy, is that we have a crawl space in this building. Each residence is 2 floors, and so there's a floor plan here just showing typical layout of each of them. We did the mechanical on the ground floor so that it was easily accessible to the Rose Villa maintenance staff. And in order to fit both our hot water tank inside the room, as well as our unit that does our air conditioning, heating, ventilation, filtration, and humidification control, we ended up sinking the actual tank itself and setting it on the floor of the crawl space. So there's an actual hole in the floor that the tank goes down, and then we're able to sit our mechanical equipment above that and have both units within a small room. And obviously, because the compressor is outside, we don't need that indoor air volume to serve what you would do sort of unitary heat pump. So probably what's more interesting to a lot of people is the diagram. We worked with interface engineering. Once we kind of had a concept, we brought them on board as a partner to help work through some of the finer details of what that distribution system looks like. And so we landed on the most straightforward approach, which was 1 circulation pump per tank. And we use a series of controls on our projects. We found a lot of success with motion activated in bathrooms, and then in kitchens, because there's a lot more traffic in there, we actually use a manual push button to trigger the recirc. So in this particular project, whether it's say residence A or residence B, water will circulate through their system when it's triggered on the pump. There's a series of backflow preventers to prevent the water from mixing back in. It's been a very successful installation for us. I will say we've been using Sanko's for a little over, I think, a decade now, and it's important to make sure that installers follow the installation instructions, in particular the types of piping that are used, because with chlorinated systems in our public water, combined with recirc pumps, which are moving water at a faster rate, and obviously a high temp, Sanko's, you can set them, and they work best if they're set to a temperature usually around 140, 150 degrees. So with high temp chlorinated water and a faster velocity, you need a high performing pipe, not a standard PEX pipe, between the actual outdoor compressor and the tank. And that's a key thing that often people don't realize when they're working on these types of systems. And here's, ours, like I said, we'll do a ceiling mounted in this project motion right inside a bathroom entranceway, so that when somebody physically walks into the room, it triggers a recirculation system. Nobody needs to really think about it. We've also done them underneath, say, a floating vanity. That's another good location. But in this particular project, the ceiling was the most appropriate. And then, like I mentioned, in the kitchens, usually right by the sink, we'll install a push button to activate the hot water there. It's just usually on the face of the millwork. And that does take a little bit of onboarding and training with building owners and occupants, just to get familiar with it, because it's something that they've never really done before. But we do a kind of a trifold, really quick cheat sheet for the residents at Rose Villa. So when they come in, they both understand how to run their what this button is, what it does, but there's also information about the other unique high performance systems in there, ventilation, etc. And so that's it, just kind of a quick overview of kind of how we looked at bringing some efficiency, reducing the number of actual heating, hot water heating units that we need, and trying to set them up in an efficient way that delivers hot water quickly. And if people have questions, we'll look here through the chat and see.
Yeah, I think that this first question gets to the metering question when you split a unit, but I'm wondering if this is senior living, did you not have to worry about metering and then charging water usage per unit?
Yeah, it's a great question. Yeah, we're fortunate we don't have to worry about it at this property because water and utilities are included in the agreement that each resident has with the community.
John, you have done the setup or a version of this in another property. I'm wondering, did that apply over there as well, the metering challenge, or I'm thinking of the Tillamook Row.
Yeah, that's exactly, yeah, Tillamook Row. I am not 100% sure. I don't believe that that is shared in the same manner. It's a similar setup. I'd have to actually look and figure out. I'm not sure on that one. That project was completed right as I came on board with Green Hammer years ago, and so I'm not as familiar with that one.
Folks, feel free to raise hands or put questions in the chat. I had a question on sinking the tank into the floor. I'd never seen that before. What were some of the advantages and disadvantages of that? I mean, I'm wondering about the penetration in the home. How do you seal around it? And yeah.
Yeah, so yeah, very unique. The reason we're able to do it is that the crawl space is conditioned crawl space. And so it's part of our thermal envelope. We don't need to worry about air sealing. We don't need to worry about thermal control. And there's actually a hatch right in front of it too, so that you can stand and have that working area code-wise in front of the equipment. And so, yeah, it's a very unique, we had never done it before, but boy, when a client's really pushing you to like minimize the footprint, maximize the square footage, yeah, it was a great collaboration in ways of figuring out how to do it. Yeah, there's a floor drain down in the crawl space. It's fairly straightforward. We've also got mechanical air distribution down there as well.
How many units would you serve as part of, with a Sanco? It seems like you did two units, one with one outdoor unit for each unit, and then sharing a tank. Would you go up to 4 units per Sanco? Have you explored pushing that?
We've explored pushing it in the past, and it's a trade-off between the amount of space that the tank takes and setting. So from a design standpoint, we try to many times with our multifamilies come with one plan that can be repeated over and over and over. And it may not seem like a lot, but when we have to come up with one room, let's say, that fits a larger tank between 2 units, there's an oddball space that kind of can throw off the plans, but it's definitely possible. And up in our region, we have a company called Small Planet Supply, and they have I can't remember what they call it, but it's a pre-designed. Sorry, go ahead.
Water drop?
Yes, water drop. Thank you. Yeah, which is a larger system based on Sanco. It's a pre-designed kit, essentially, right, that you can deliver to facilities and basically swap out or get running up on larger hot water installations very quickly. Everything's pre-mounted, pre-plumbed. So yeah, it can be expanded. It's just really about space allocations and then compactness, really, in thinking about your distribution system and the efficiencies there. I mean, you're limited to, I think right now, I think they increased it. I think it's 75. It used to be 60 feet between the indoor unit and the outdoor. I think now it's somewhere in the 70s. So that's a factor too. If you're doing multifamily that's more than 2 stories and you're thinking about rooftop and then you've got a tank, say, on the ground, you could start to get into both the vertical lift challenges, it's just in terms of also distances, even if you have tanks on floors. So, yeah.
Right. Kashmira, I wondered if you had any thoughts, compared to the HopeWorks project that Bonneville and Ecotope worked on, and compared to this.
I think I'm not sure if John worked on that project too. I think HopeWorks had like a booster system and was like a vertical stack. And I don't think it had a hot water recirc pump like you have put in this design, but I do think that's really interesting because we've heard people say that lossage in the distribution system runs from a third to upward of 50% of the system COP. So I like to see this design. I can't recall, I might have read the diagram wrong. I thought I was looking at a booster in a unit, but maybe it's that recirc. I'm not sure.
Yeah, we just had a recirc pump. And then, we try to, the design of these and the way that they're laid out is that the actual kitchens and bathrooms, they're back to back in a couple situations. It doesn't work perfectly for each 6 units, but we try to get some efficiencies in minimizing the design and the piping, and then getting the piping sized as small as we can with our flow rates.
That's
Thanks,
great.
Abby, I see your hand up.
Yeah, do you, is this system in operation now with residents using it?
Yes, yeah, it's been in operation for about 3 years now, almost 3 years.
And what resident feedback have you gotten on the manual button for demand recirculation in the kitchen?
Like anything that's new, and also maybe more in the senior community, it takes a bit of getting used to. But once, you get familiar with just the act of pushing the button, we don't get any complaints about it after those initial sort of kind of learning curve on it. Yeah, it's been good. Sometimes in some residences, this is an island in the kitchen where the sink is. A lot of times we'll make it a toggle switch sometimes on the wall instead of an actual push button, because sometimes the push button is forgotten. It wouldn't work really well on, say, Airbnb or those types of facilities. But yeah, here, these owners have really bought into. There's a huge waiting list to get into our net zero homes on this particular property. People like it. They're kind of advocates themselves, so they're very interested in working on adopting some of the behavioral changes that come along with living in more high performance buildings.
Great. Exciting. Any other projects in the works using a heat pump water heaters in this kind of configuration for multifamily, John?
No, not at this time. There's a few that are always early designs, but I think the nature in Portland right now in our commercial multifamily is a bit quiet with some of the financial challenges. So hopefully things will pick up in a couple of years and we'll see some things that we started designing. But yeah, we've looked at repeating this on future designs because of its efficiency and it's just great dependability and performance as equipment.
All right. Well, thanks so much for joining us. Really appreciate you sharing your perspective, on this low-rise multifamily and some interesting ways to add heat pump water heaters to units. So thanks so much, John.
Yeah, thank you for inviting me. Appreciate it.
Kashmira, over to you for the final word.
Yeah, do we have any other slides? I see we're on 50. If we roll back, I just want to double check we're not missing anything.
I don't think so.
Okay, super. Okay, great. Well, first of all, I want to thank all our sponsors. Sponsors. Oh my goodness. Thank our speakers, wrong SP word. Sorry about that. Presenters for sharing today, and even more so the engaged people that join the calls and ask the meaningful questions that help in application and advancing the market. So thanks to all of us participating and being engaged.
Great. we'll hopefully see lots of folks at the Hot Water Forum, and we'll send out slides and recording as soon as we can.
Take care, everyone.